Welcome back, everybody. We are now on episode 5, the electrochemical series. The electrochemical series is in your data book. It's on page 4. It's item number 2 on the list. Point is, this is one of your best friends in the exam. So let's have a quick look at what we're looking at. The first thing, just to be aware of what's going on, the first thing I want you to notice is that all of the chemical reactions are half equations. They're half equations and they're all written in their reduction form. They're all written as reduction. And by that, what I mean is that the electrons are all reactants. They're all on the left. So that's the first thing to notice. The reason I mention that is because sometimes on an exam question, they might give you these things and they might give you them the wrong way around. It's a pretty common trick. The second thing to note is this double-headed arrow thing that they give us. This double-headed arrow means it's possible that these equations could go either way. They're not going to go both ways. You're going to pick which way they're going to go for you. I'll show you how to do that in a minute. And the final thing I want you to notice is that these numbers here, the standard electrode potential, we call that the E0 value. They are all based on this standard. The standard is this hydrogen reaction in here. So we set that to 0, and everything that's above is positive and everything that's below is negative. Finally, I want you to notice that of these E0 values, that these E0 values go up in order. The largest positive is at the top, and the largest negative is down the bottom. I want you to notice that because, once again, a really common exam trick that they'll play on you is they'll give you a bunch of half equations and they might put them out of order, and you've got to see if you can sort them out into order first. So this is the order. These E0 values are the order. Using the electrochemical series, you might recall a bit from year 11. If you don't, that's okay. The only thing that's different between the year 11 data book and the year 12 is the E0 values. But let's do a recap anyway. What I want you to know, and what you hopefully remember from last year, is that things will go what we call downhill. They go downhill. Downhill means that it is going to go from this side here to this side here. That's considered downhill. Just imagine you're walking along, you go downhill. You're not going uphill, you're going left from right, it's downhill. That means that this will react, or will react. This will react. If it goes downhill, it will react. It'll be spontaneous. And the fancy schmancy word we'll use, particularly for later on when we do galvanic cells, is we would call this a galvanic reaction. So the first thing we're going to look at, the first bit for this chapter, is using the electrochemical series, and we're looking for downhill spontaneous galvanic reactions. Later on we'll use it for something else as well. However, for now, let's see what we can do. If we have a look at it, the reactions towards the top, the ones up here, the very top one up here is F2. That means that it is the most likely to go that way. It's the most likely to perform in the direction, the forward direction. It's the most likely to do reduction. I can't read my own writing underneath that. It's the most likely to reduce. Let's see if I can move that down. Oh, beautiful. It's the most likely to reduce. So that one at the top is the most likely to reduce. If it's the most likely to reduce, then we could say that this thing involved the the F2. If it's the most likely to reduce, it's therefore the strongest oxidant. Remembering, of course, that if it reduces, it's called the oxidant. If you look down the other end of the scale, though, these ones down the bottom, down this end, these are the most likely to go the opposite way, to go backward. And if they're the most likely to go backward, then they're the most likely to oxidize. And if they're the most likely to oxidize, we would say that they are the strongest reductant. So the strongest reductant, I haven't got them all on here. I've moved the table down. The strongest reductant on the table we get on the data book would therefore be solid lithium. This is the most likely to go that way. It's the most likely to be oxidized. Therefore, it's the strongest reductant. Ladies and gentlemen, that is some of the stuff that I want you to know. So we'll go here, we'll insert a new slide so I can get all of that crazy writing off. I'll put that there. That doesn't work. Copy, paste. Paste isn't an option. That's not. Don't panic. Okay. So we've got that there for later because we're going to be using this now. Okay, let's go and have a look. So once again, on your PowerPoint, you've got that idea that I said about oxidizing strength and reducing strength. We've got a wonderful summary there of everything that you're supposed to know that's on the study on. Let's have a look straight at what they've done on past exams. So some of the past exam papers are using this information. So we have to see if we can work out these two options, which is the strongest reductant. Strongest reductant. So given what we kind of learned before, we're looking for the one that's at the lowest, the strongest reduction, most likely to go backwards. We're looking for this one here out of these two. So what do we got to be careful of? Some of the common tricks. Have they written them the right way around? Have they written them as reduction? Yes. They're both written as reduction. That's brilliant. We haven't been given E naught values, so I don't know if they're in the right order. I'm going to check. So we've got Ca2 plus and I2. Just jump back here for a second. Let's see if we can find either of those things. Oh, I can see one right down the bottom. So I'll move this up a little bit. If we have a look here, I can see the equation that had the calcium on it. Oh, that's not it. It's there. There's the calcium reaction. And the other one that we looked for was the iodine, and that was that reaction there. So the two that they mentioned, you might notice that on the exam question, they put them upside down. What this means is that out of these two, this here is the most likely to reduce. This is the strongest oxidant, and therefore this thing here is the strongest reductant. I'm not saying the strongest in the world, I'm saying the strongest out of the two that they mentioned. So if we go back to the question, identify the strongest oxidant and the strongest reductant out of the two that they gave us. Well, we said the strongest reductant was the Ca plus. So the 2 plus was the strongest reductant. So I'm loving that. Is that right? Hang on. No, Ca solid. That's more like it. I don't know what that means. Oh, that's much better. So we identified that the strongest reductant was this one, and we said that the strongest oxidant was I2. This would probably be a bit easier if I had the data book on the same page, but probably run out of space. Do you understand that? Look for the tricks. What was the trick there? I reckon the trick there was they put them out of order, put them upside down. The next one, really interesting. It doesn't seem to give us enough information. It says, write a balanced overall equation. Overall equation means that we're getting the two halves. We could use Peter Blackshaw wears heels every Saturday. However, I've got no information apart from one little thing, H2O2. It's the only thing mentioned. It's the only thing I'm aware of. It doesn't say anything in there about it being a solution. It doesn't say anything in there about it reacting with anything. Some of you might know the reaction that this stuff goes through. Normally, it says it's being a reductant. So it shows that hydrogen peroxide reacting as a reductant, and it says to use the data book. Okay, let's go and use the data book. So here's my numbers from before. Let's get an eraser up. Medium eraser I've already got. So now I'm looking for anywhere I can find hydrogen peroxide. So hydrogen peroxide, I am looking for hydrogen peroxide anywhere I can see it. There it is there. I'm going to highlight hydrogen peroxide and I can see it above that. I should have probably spotted that one first. It's in two places. So if I look at this, hydrogen peroxide is the most likely to reduce. It's the strongest oxidant. And weirdly, it's also a reductant. So given what's going on there, let's go back to the question. Shows hydrogen peroxide. Write a balanced overall equation that shows hydrogen peroxide acting as a reductant. So I need it to be a reductant. I need this half equation here. I need this to be occurring here. I need this to be happening backwards. So for this to be happening as a reductant, I need oxidation. So I need oxidation to occur. So this equation is going to happen. It's actually the backward version of it. Now the only way I can get a backward version of this chemical reaction, it's a H, that's a plus, plus 2 electrons. The only way is if I have something else above it to react to it, downhill reaction. It wants me to do an overall equation showing that this is, it doesn't say which thing it wants me to react it with. I could react it with anything above it, anything that I can think of above it there. So why not pick a nice easy one? Why not pick, I don't know, silver? So I'm just going to pick any old reactant above. And if this thing here meets this thing here, it will react. And it's going to react in the following way. So I might have to jump between them because I probably forget what's happening. But I've suggested that I can pick Ag plus an electron, turning into Ag solid. That's one half equation. And now the other half equation, I need this thing to be reacting like it's a reductant. So I need the electrons on this side. So the equation we picked out before was this one here. Let's see if we can try and remember it. O2, 2H plus. So it's going to turn into that. I should probably rub it out a bit. Give me some more space. So this is going to be, we say O2 plus 2H plus 2 electrons. So I used the data book. I found the two half equations. I showed H2O2 being a reductant. The other half I could have picked from, I was going to say a dozen, but 1, 2, 3, 4, 5, 6, 7, 8. I could have chosen from 8 different possibilities. I deliberately avoided the other H2O2 just because I thought the examiners might think that I didn't know what I was doing. The final bit to get my full marks is that I need to do it as a balanced overall equation. So to put these two halves together, I've got to remember that my electrons are my link. This side's got 2 electrons, this has only got 1, so I'm going to do that. Let's put them all together. 2Ag plus 2 electrons on that side of the arrow. On this side of the arrow, I've got H2O2, and that's going to turn into 2Ag solid plus O2 plus 2 plus 2 electrons. I can cancel out anywhere I want. Now the things I'm really looking for are electrons. So I'm going to cancel them out, and the states I can use from the data book that said that was aqueous. It said this was aqueous. That was solid. That was a gas. That's always aqueous. To make it nicer, I'm just going to rub out these bits here, maybe. And that there is one of 8 possible balanced overall equations, I could use this H2O2 being the reductant. So just to clarify, this half equation was critical. This is one of 8 I could have chosen. What I was really hoping for was anything that was above this. Okay. We'll have to rub that out. It's a bit of a mess. Okay. While I'm rubbing out, how are you guys going? Remember, if you need to talk to me, let me know. Shoot me an email. We can hook up a Google Meet. Otherwise, keep doing what you're doing. Stay friendly. Okay. The next question, this is from the chapter textbook. So, you know what, we'll pick a couple out. And basically, this one here says we have to identify anything that will be spontaneous. And when you say spontaneous, you're thinking the following terms. You mean galvanic, which might make not much sense yet, or you might think the word downhill. So we're looking at downhill on the electrochemical series. In the first one, I might do a couple. Silver metal. Silver metal means Ag solid is going to be placed in copper 2 nitrate. Copper 2 nitrate, well, that simply means it's Cu 2 plus, and the nitrate means it's NO3 minus. So I'm going to go back to my electrochemical series, and I'm just going to circle these things, find these things on the electrochemical series, and see if it's a downhill reaction. So to see the downhill reaction, I'm looking for copper 2, and I'm looking for silver metal. So silver metal is here, and copper 2 is there, and nitrate's nowhere to be seen. This is an uphill reaction. You might notice I only circled the 2, copper 2, not the whole equation, and not the copper solid. Copper solid's not there, copper 2 plus is. Same with the silver. The silver's here in solid form, that's why that's the only one. That's uphill, no reaction. So this one will not, react. Let's pick one further down just to get out of the way here. Lead 2 nitrate is poured into a beaker containing zinc granules. Now, zinc granules jumps out at me. That means it's solid zinc. Lead 2 nitrate, well, that means it's Pb2 plus. And nitrate, NO3 minus. Now, you might remember from before that nitrate isn't on the series. It's not on the series. Everything's not on this. Not everything is on the series. And it's pretty unreactive, so that's why they don't bother. So I'm looking for this time, I've already forgotten. It was zinc solid, certainly. So let's find zinc solid. Can anyone see it? Let me know. Yep, thanks. There it is. Got it. There's solid zinc. And the other thing was Pb2 plus. I can just see Pb2 plus. Now, looking at this, you're walking along and it's downhill. Downhill, galvanic, spontaneous, tick. So this one will react. I did that again. Come on, people. Stay with me. Stay with me. This one will react. This one will react. Have a crack at some of the other ones. Let me know if there's any problems. Once again, the second lot of questions down here are very, very similar. You have to tell me which ones will react using your reactivity series and then write an overall equation. For the final one, name the two. Just tell me something that would react. This one might be an interesting question, but who knows? And finally, to end this chapter, there is the chapter review questions. Ladies and gentlemen, it's been emotional. This has been the redox chapter. Please let me know if this is of any use to you at all, because this has taken me 1.5 days, and you might hear this as a waste of, you might hear this as terrible, but I can assure you that the ones that I've not put up are even worse. Thank you for your time. Keep me in the loop.